So you're contributing more to the overview effect that is so commonly described by astronauts that have been in space.
Well, there is certainly an effect of seeing the planet from this perspective. And if you talk about beauty, Earth is amazingly beautiful when your feet are firmly planted on the ground, and it's beautiful from space, and it's hard to say what is more beautiful. And I think it's because space is a unique opportunity. We seem to focus on the beauty of being in orbit. If we had people living their whole life in orbit, when they'd come down to Earth, they would probably think that was the most beautiful perspective they'd ever seen.
I love your chemical engineering background, and aren't many, I don't know how many people even know a chemical engineer, but I think of you as everyone's chemical engineer, given your visibility in space and what you've done with your career. Tell me about your commitment to science on the ISS.
Well, I'm here. I'm working hard on the mission, and I apply my chemical engineering background where it's relevant, and really what my chemical engineering background brings me is a different set of analytical tools to apply to what's going on here. And if you look at our life support system, they are nothing more than little miniature chemical plants that you see scattered all over Earth, but we have them here in a miniature version in our spacecraft that provide us with all the elements of gas and breathing mixture, CO2 scrubbing, water, all the things that we need in order to stay up here on station.
Somebody had to figure out how to turn your pee back into water. And that's a chemical engineer, correct?
Yes, and I like to refer to that as the coffee machine, because on station, imagine you wake up in the morning, and on station, we do exactly the same thing that everybody on Earth does. We make a beeline for the toilet, and then after that, we do what everybody on Earth wants to do. You go into the galley and you get yourself a bag of coffee. And if Sunday morning, I might drink out of the zero-G cup. But on work days, it's a bag of coffee. And you got to realize, where did the water come from for this bag of coffee that you're drinking today? And that's why I like to refer to the regenerative life support system, as we call it. I like to refer to it as a coffee machine. It could take yesterday's coffee and turn it into today's coffee.
Now, I see what you did there. You gave a shout out to your zero-G mug. This is something you patented in space, correct?
We do have a patent on that, actually 2 patents, and this is with my colleagues at Portland State University, Mark Weisslogel, co-inventors, et al. And it turns out that all the things that are patented dealing with microgravity are things that were thought of and invented on Earth and subsequently made on Earth and flown. And this happens to be something that came about because I was on space station, and I guess necessity is the mother of invention. It's like I'm tired of drinking coffee, sipping coffee through a straw from a bag. I want to have the Earth experience. And that's the root of the zero-G coffee cup, invented in space and then subsequently patented.
What is the physics of the zero-G coffee mug? You still have to do some sucking, right?
Well, no more than, I call it sipping, no more than what you do on Earth. A cup is really a gravity machine, And in weightlessness, a normal cup, the fluid would just be in a little hemispherical a blob at the bottom of the cup. And if you slosh it too hard, it all comes out and makes a mess, and you can't drink it. But with the zero G cup, it has an acute angle that runs up the side, and that acute angle incites what is called channel flow. And this was first described mathematically by Konkes and Finn, professors at Berkeley and Stanford, in a paper published, I think, in 1969. And this channel flow moves some of the fluid and has it park right up near the lip. And then all you have to do is take a sip, not unlike what you do on Earth, and it just goes right into your mouth, and then more fluid from down below comes up and takes the place. So the principle is really simple, and it's driven by capillary action.
Brilliant. Love it. Love it. So now you for a while had a show called Saturday Morning Science. Tell me about that.
Saturday Morning Science, and I've rebranded it as Science of Opportunity because I think that tells a better story. And Science of Opportunity happens on Earth. It happens anywhere there are scientists, engineers, uber geeks that are tasked with doing some programmatic work in a laboratory. And because you are there and you get an idea. It's not on the script. It's not part of the program, but you get an idea. And maybe when your major professor is gone, you can sit there and mess around with your idea in the university lab, and oftentimes come up with something interesting that becomes the seeds for the next proposal and funded research. So the science of opportunity happens anywhere there are people thinking about advancing our knowledge, and the same thing happens on space station. So I like to call what started off as my Saturday morning science, I like to call it Science of Opportunity.
So that needs two things. It needs curiosity and fun stuff to play with that is unbreakable. So we don't want you to perform an experiment and the ISS starts to deorbit, right? So you want the experiments to have guardrails at some level, correct?
Yes, and some of the like Science of Opportunity, I'm working on what I think is a fascinating observation now, where I took some leftover wire and bent it into a frame and have a little slider on the side of the frame so I can change its cross-sectional area. And then I put soap solution on that frame, and I can make an expanding, flat, thin film. And there's all kinds of observations you could make in terms of how far can you expand a film before it breaks, and then you could determine its film thickness, and then you can look at the iridescent interference patterns that happen as the film approaches a wavelength of light, and that's one of my current little projects I'm working on during my not whole lot of spare time here or off-duty time on space station.
I love that. And if you have a square wire and blow through it, it still makes a spherical soap bubble, right? You can't make a cubical bubble, no matter the shape of your wire.
You could take wire and you can make it into a cubical frame and have a stretch film in between, and there is a fellow. There's a whole arrangement of people that are into soap bubbles, and they actually make a living doing entertaining with soap bubbles. And Tom Noddy is one colleague of mine, and he has the uncanny ability of blowing a cubic-shaped soap bubble. You'll have to check out how he does that.
Well, okay, definitely. I've never seen that before. So tell me, you're going on a total of, is it a year and a half in space, total log time? Is that about right?
Yeah, this will be about a year and a half. It'll be 500 and 30 days or something total with all my missions. This mission will be 220 days by the time I come back to Earth on April 20.
So you look no worse for the wear, spending that much time in zero G. Is there changes about your physiology that you're concealing from us? Something that people might want to know happens to you spending that much time in space?
Well, there are changes that happen. Some of them are fundamental physiological fades. Some of them are temporary. One of the fades, there's bone density. You can lose bone density because your bones aren't loaded. We don't completely understand the physiological reasoning for that. But we have an empirical solution, which is called exercise, and we spend 2.5 hours every day between weightlifting and cardio exercise. And astronauts now are coming back with bone density measurements within the air bands of our machines for measuring pre-flight bone density. So that's just one example of a fundamental physiological thing. And then there's the feeling while you're up here. All these little nasty aches and pains dealing with gravity heal up after a couple of weeks, and you feel like you're 30 years old again. So I'm floating around here, zooming around here as if I'm 30 years old. I mean, go figure. And then the day of reckoning will come when I go back to Earth.
And then you'll feel like you're 90. On arriving back at Earth?
It takes a while. Maybe within a couple of days, you're back sufficiently normal that if somebody saw you walking down the street, they wouldn't even know that you'd left the planet. But there's a lot of things dealing with balance and coordination that takes 40 or 50 days to get over. And then there are more subtle things, like if you did lose bone density, it takes 6 months to a year to regain your bone density. And then there are some fascinating eye retinal issues that we're uncovering from people that have spent a long time in microgravity.
To what pressure is the air in the space station set to? Because it's probably not sea level. And is the pressure a factor that it's affecting vision and the pressure on the eyeball?
The atmospheric composition and pressure is basically that on Earth. And this was chosen by design because station was designed from the ground up to be a scientific research laboratory. And they didn't want every single item that comes to station to be special engineered, designed like what happened on Apollo. They wanted to be able to bring a commercial off-the-shelf instruments onto station with maybe some modification for spacecraft safety, but outside of that, basically unmodified. For example, this microphone I'm talking from is just a standard off-the-shelf microphone. And in order to have that happen, you need basically 1 atmosphere pressure. It's around 750 millimeters of mercury total pressure, 20% oxygen, 79% nitrogen, and then 1% other impurities that just kind of accumulate here.
So, so that means that the whatever's happening to your eyes is purely a zero-G phenomenon. It has nothing to do with changes in pressure. Yeah. That's interesting.
We've got a whole cadre of folks on the ground trying to look at the eye retinal issues. And there's like 4 different maladies. We've got disc edema, we have cotton wool spots, we've got choroidal folds, and globe flattening. And these are the biggies that happen to your eyeball when you're up here. And we've had some crew members have a 2 diopter shift in their vision when they come up to station after being here for a while. So it's a significant thing. And all of these maladies affect people on Earth. They're just more intense in a weightless environment. And if we could crack the nut in terms of why astronauts in the middle of being a healthy state get these maladies, it should shed some light on the maladies for everybody on planet Earth that don't get a chance to go into space but are suffering from the same thing.
Excellent. Excellent. The medicinal value of these things happening to you to help everyone else. That's beautiful. So, last question.
And Neil, Neil, let me point out that has been a standard discourse through the annals of time for exploration. And you look at transoceanic exploration and the advent or the spread of scurvy, and then the eventual solution for scurvy, which helps everybody on the continent that doesn't go on transoceanic explorations. This is a standard motif from what happens when human beings go off into the wilderness, go off into the frontier, and not only do you learn new things about where you're going, but you learn new things about your own physiology and your own self, and that could be applied to everybody back on the home planet.
Beautiful, beautiful. Is this your last trip, or are you going up again?
Go ahead with your question.
Yeah. Is this your last voyage, or are you going to take another trip?
Oh, is this my last mission? Well, you know, I'm going to turn 70 on orbit. And I look at John Glenn, who is one of my childhood heroes and is probably one of the reasons why I even thought about becoming an astronaut. He flew on the shuttle as a full shuttle crew member at age 76. And according to my watch, I've got a few more good years left for space flight. So who knows if this is going to be my last space flight. As long as I can meet the medical requirements and the physical fitness requirements, I'm game for flying in space as often as NASA will let me escape from flying a desk.
Love it. Well, thanks for making time for Star Talk. And we look forward to more of your astrophotographs to reorient our perspective on ourselves here on Earth. So, Don, a Godspeed to you.
Well, thanks, Neil, and I'm in the process of taking some more astrophotography right now in the cupola, because we now have the Northrop Grumman vehicle undocked, which was blocking our starboard view, and now we have full 360-degree view. So I'm in the process of enjoying the new expansion views, and it's going to lead to some more compositions of astrophotography that I will be sharing here with anyone that wants to take a gander.
Station is a Houston ACR that concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications. Copy that.